Coronaviruses are a group of related viruses that cause diseases in mammals and birds. In humans, coronaviruses cause respiratory tract infections that can range from mild to lethal. Mild illnesses include some cases of the common cold, which has other possible causes, predominantly rhinoviruses, while more lethal varieties can cause SARS, MERS, and COVID-19. Symptoms in other species vary. In chickens, they cause an upper respiratory tract disease, while in cows and pigs they cause diarrhea. There are yet to be vaccines or antiviral drugs to prevent or treat human coronavirus infections. Coronaviruses constitute the subfamily Orthocoronavirinae, in the family Coronaviridae, order Nidovirales, and realm Riboviria. 5-6. They are enveloped viruses with a positive sense single-stranded RNA genome and a nucleocapsid of helical symmetry. The genome size of coronaviruses ranges from approximately 26 to 32 kilobases, one of the largest among RNA viruses. 7. They have characteristic club-shaped spikes that project from their surface, which in electron micrographs create an image reminiscent of the solar corona from which their name derives. 8. Coronaviruses were first discovered in the 1930s when an acute respiratory infection of domesticated chickens was shown to be caused by infectious bronchitis virus, IBV. 9. Arthur Schock and M.C. Hahn described in 1931 a new respiratory infection of chickens in North Dakota. The infection of newborn chicks was characterized by gasping and listlessness. The mortality rate of the chicks was 40 to 90%. 10. In 1937, Fred Baudet and Charles Hudson reported that they had successfully isolated and cultivated the infectious bronchitis virus which caused the disease. 11. In the 1940s, two more animal coronaviruses, mouse hepatitis virus, MHV, and transmissible gastroenteritis virus, TGEV, were isolated. 12. It was not realized at the time that these three different viruses were related. 13. Human coronaviruses were discovered in the 1960s. 14. The earliest ones studied were from human patients with the common cold, which were later named human coronavirus 229E and human coronavirus OC43. 15. They were first imaged by Scottish virologist June Almeida at St. Thomas Hospital in London. 16. Other human coronaviruses have since been identified, including SARS-CoV in 2003, CoV-NL63 in 2004, HKU1 in 2005, MERS-CoV in 2012, and SARS-CoV-2 in 2019. Most of these have involved serious respiratory tract infections. 17-18. The name coronavirus is derived from Latin corona, meaning crown or wreath, itself a borrowing from Greek cor, knee, garland, wreath. 1920, the name was first used in 1968 by an informal group of virologists in the journal Nature to designate the new family of viruses. The name refers to the characteristic appearance of virions, the infective form of the virus, by electron microscopy, which have a fringe of large, bulbous surface projections creating an image reminiscent of a crown or of a solar corona. This morphology is created by the viral spike peplimers, which are proteins on the surface of the virus. 821. Coronaviruses are large pleomorphic spherical particles with bulbous surface projections. 22. The average diameter of the virus particles is around 120 nanometers. 12 micrometers. The diameter of the envelope is ~80 nanometers, 0.08 micrometer, and the spikes are ~20 nanometers, 0.02 micrometer, long. The envelope of the virus in electron micrographs appears as a distinct pair of electron-dense shells. 23-24. The viral envelope consists of a lipid bilayer where the membrane, M, envelope, E, and spike, S, structural proteins are anchored. 25. A subset of coronaviruses, specifically the members of beta-coronavirus subgroup A, also have a shorter spike-like surface protein called hemagglutinin esterase, He. 5. Inside the envelope, there is the nucleocapsid, which is formed from multiple copies of the nucleocapsid, N, protein, which are bound to the positive sense single-stranded RNA genome in a continuous beads on a string type conformation. 24-26. The lipid bilayer envelope, membrane proteins, and nucleocapsid protect the virus when it is outside the host cell. 27. Coronaviruses contain a positive sense, single-stranded RNA genome. The genome size for coronaviruses ranges from 26.4 to 31.7 kilobases. 7. The genome size is one of the largest among RNA viruses. The genome has a 5-methylated cap and a 3-polyadenylated tail. 24. The genome organization for a coronavirus is 5-liter UTR replicase/transcriptase spike, S, envelope, E, membrane, M, nucleocapsid, N3'U.T.R. Poly, A, tail. The open reading frames 1A and 1B, which occupy the first 2/3 of the genome, encode the replicase/transcriptase polyprotein. The replicase/transcriptase polyprotein self-cleaves to form non-structural proteins. 24. The later reading frames encode the 4 major structural proteins, spike, envelope, membrane, and nucleocapsid. 28. Interspersed between these reading frames are the reading frames for the accessory proteins. The number of accessory proteins and their function is unique depending on the specific coronavirus. 24. Infection begins when the viral spike, S, glycoprotein attaches to its complementary host cell receptor. After attachment, a protease of the host cell cleaves and activates the receptor-attached spike protein. Depending on the host cell protease available, cleavage and activation allows the virus to enter the host cell by endocytosis or direct fusion of the viral envelope with the host membrane. 29.